So now we're looking at the merit and distinction part of software design development assignment 2. These are the three criteria. Just to remind you, you've got P5, M1 and D1. We're now looking at M1 and D1. So first of all, to explain the importance of quality code, and then to discuss the factors that can actually improve the readability of code. Just as a quick recap, you should have already done P5. The first part of that was using stuff that you've already created for your software systems analysis and design unit, talking about how design principles are used in each stage of the software development lifecycle, so explaining what happens at each of these stages. So remember, you can use your systems analysis and design assignment work for this part. Then you should have done part 2, which we did in the lesson last week, which was looking at these different software structures, things like functions, procedures, classes and objects, abstraction of data, predefined code and quality of code, and talking about where those things fit in to the development lifecycle. Now the next bit, we're looking at task B, which is covering M1. What you need to do for this is write a report of around 500 words that explains the importance of quality code. Your report should cover the following quality issues, give an example of each and explain what they are, why they're important, and how you can basically use them to improve the quality of your code. I would start with a little introduction to your assignment, so something along the lines of good quality code is important because, and the reasons for that are kind of twofold. You've got, firstly, from the user's point of view, the end user that's going to be using your software. They want it to be good quality, they want it to work well, be efficient, etc. And also from the point of developers, so other developers that have got to maintain the code, work with it, they want the code to be good quality as well. So start with a little introduction explaining in general terms why good quality code is important. The first part of quality of code is looking at the efficiency of the code. This essentially means how well the code works, how quickly it runs, and how it performs tasks in the most efficient way in terms of things like speed and performance and so on. Why is it important? Well, it's really important because in this day and age we want everything to happen really quickly. It can't take too long to perform a particular action. It's got to run the code straight away. When you click on something, you want responses straight away. When you set it to process a task, you want it to be done as quickly as possible. It should also, your code shouldn't be using resources unnecessarily. If you think about it in terms, although computers these days have a lot of processing power, a lot of RAM, etc., and fast processors, but we use our computers for a lot of programs at the same time. So we've got lots of different tasks simultaneously running. We don't want one program to be slowing up the whole system. So if it's inefficient code that's using up lots of memory and lots of processing power, then it's going to be making the rest of our computer run slowly, and that's not a good thing for the users. In terms of writing efficient code as well, the less amount of code you can actually write, the better. We don't want to write unnecessary code or lots of code that's just not needed. So the fewer lines of code is always better, and that means actually the programs will compile quicker. The actual program software itself, if you had to download something, there'd be less of it to download. So generally, less code is a good thing because of the amount of time it takes to install, to compile, to download, and so on. Another good thing about efficiency, and this is probably from the point of view of a developer, is that really good code that's efficient will be reusable. So it means that the developer can efficiently use that code because they can reuse the code in other programs that they're writing. They can reuse code throughout the same program. If it's modular, by writing different procedures, then you just need to call the procedures from different parts of the code. Again, that's much more efficient than having to retype the same piece of code in lots of different places. One little example just to mention about the actual efficiency of code. I mentioned before about you mustn't write code that's unnecessary, and it's really important that you're using the resources as efficiently as possible. One little tip, when you're declaring a variable, it's really important that, particularly when you're using loops, that you don't declare a variable inside the loop. When you declare a variable, the computer is allocating an area of memory in the RAM that's going to store information. That's what a variable is. You give it a name, and it's a location in memory to store some data. If you declare that variable before you start the loop, that's fine. It allocates one area of memory and gives it a name that you can refer to in your code. You can then, through the loop, you can change the values that are stored in that variable, and that's fine. It's just updating and modifying the value that's stored in the variable, that area of memory that you've allocated. If, however, you declare a variable inside a loop, that is actually creating or assigning an area of memory every time the code loops. It's going to create another area of memory. Another location is going to be allocated to store that memory, that value. So if you're running a loop that runs, say, 100 or 1,000 times, you will have allocated 100 or 1,000 separate locations for the memory to be stored in, or for the data to be stored in. So you're making lots and lots of new variables. You're declaring the variable every time you run the loop, actually creating a new area to save it in, rather than just reusing the first one. So it's much more efficient. There are lots of other ways that you can save save the amount of code, but that's just one very typical example. So, reliability. This is really important. It's about code working every time. So the code is reliable, it does exactly what it's supposed to do, and it works every time. Given the same inputs, it will always produce the same output. That means it doesn't break, and it's reliable. Why is it important? Well, obviously it's really important to the end user that the program, the software they're using, doesn't crash, doesn't cause errors, they don't lose their work, and that they know that given the right inputs, the outputs that they're getting are correct. If they're trying to generate calculations or whatever it might be, they know that what comes out at the end will be what they're expecting. So that's why it's really important. It can't crash and cause errors. The other thing is the way to actually put reliability into your code and make it good quality from that point of view is you can build in validation into the code, so making sure that the inputs that the program is expecting are validated. Remember the phrase garbage in, garbage out. Making sure that the inputs are all correct or at least valid means that the outputs should be what the user is expecting. Also, actually how you can actually handle errors. So you can put error handling code into your code to actually deal with what would happen if you got an error. Will there be error messages to help the user actually fix the problem so they know what's going on, or error messages that will help a developer, so the developer can actually fix the code or make amendments and change it so that it actually will work more reliably in future. Again, to ensure the reliability of a code, you need to do thorough testing. The testing is going to be really important to make sure you've fixed any bugs, and with that thorough testing, you've got to really test it so that, one, you've eliminated all the bugs, and 2, that you've actually put it through its paces in terms of the real ways that it's going to be used, and not just testing once or twice, but testing lots and lots of times, so that you really are 100% sure that the code is actually reliable. It's also, in terms of reliability, documenting the requirements in terms of perhaps the hardware or software that's required to actually run this program. If you've got good technical documentation which suggests that the system requirements that you need, then obviously if the system that you're using isn't actually good enough, doesn't have all the requirements, then it's not your code itself that's going to be blamed for the reliability. You know that actually it's not the appropriate resources that you're using, or not the appropriate hardware or software for the system. So it's not actually your code that's not reliable. It's just the fact that you haven't got the requirements needed for it. So robustness is kind of similar to reliability, but it's more about the program actually working in unusual circumstances. So it means that with kind of extreme data, or when the program's really put under stress, that it still works. So it's still able to process large amounts of data than normal, or kind of various different circumstances which aren't its kind of usual run-of-the-mill type things. So if it's robust, it will be able to handle lots of data and quite extreme data and still work efficiently. Why is this important? Again, it's really important for the users that no matter how much pressure they're putting the program under, no matter how much work they're trying to do, that it still works properly, it doesn't lag, it doesn't cause a crash or freeze the computer, it doesn't cause other programs to lag or freeze. It still allows the computer to be running multiple programs and so on. So it's really important from the user's point of view. The ways to make sure that that your programs and your code are robust is to test for the extreme data. You'll know from previous units that when you're testing, you'll use normal data and you'll also use extreme data. So really testing a program to its limits by running it with input data that's perhaps unusual or really pushes it to the kind of boundaries of what's expected, just to make sure that the program really is robust. Again, similar to reliability, you need to have really good error handling code. It needs to give the user error messages so that they know why perhaps it's working slower than normal, but are confident that it will actually still complete. Things like a progress bar are really good. It gives feedback to the user so that they know that it's that the program is still working. You don't want to just be sitting there looking at the old egg timer, wondering whether the program is actually working or not. So in that case, error messages or at least progress updates and status showing that it is working really helps in this terms. Also in terms of the error messages and being able to handle large amounts of data or unusual pressures on resources and so on is really good from the coder's point of view. So future developers know why the code's been written in that way. They know it will be able to handle unusual circumstances. So usability is really important. What it means is that program and the code itself is easy to use. So that's again looking at it from kind of 2 points of view. The program itself is easy to use for the users, and also looking at it from the point of view of developers, that the code is easy to understand when they're coming to edit or maintain it. Why it's important? Again, for the users, it shouldn't take a long time to learn. It should be intuitive. It shouldn't be too complex. You should be able to carry out the tasks in an efficient way with as fewer inputs and commands as possible. Just those necessary button clicks that you need to actually use the software, rather than having to go around things in a kind of long-winded way. That's why it needs to be really easy to use. From the coder's point of view, usability means that the code is actually easy to understand, therefore it's easy to edit it, adapt it, add new features, things like that. A big way of making the program itself usable is having a good graphical user interface. So that's kind of really important. Having things like prompts to the user, having help functions, having hints and tips. Again, as we mentioned earlier, having error messages or progress status indicators will really help make the program really usable. And following those classic important factors and kind of golden rules of any graphical user interface will make it much more usable. Also, when you're thinking about usability in terms of graphical user interfaces, the code, the way it's written for the future developers, again with the code that runs well, or code that's written well, you'll be able to use lots of inbuilt features. You'll be able to use the integrated development environment to update the code and maintain it really easily. All this comes from understanding exactly what the users need, and again understanding what the future developers will need. This comes from good systems analysis to start with, looking at the design, not just the design of your program and the interface for the user's point of view, but really good design in terms of how the program is actually written and actually coded, how it's modular and things like that, to make sure again that it's really usable code in terms of from the developer's point of view. So portability, this aspect just means that you can run your code on lots of different platforms or different devices. It's portable between different operating systems, different hardware, software, and so on. Why is that important? Well, it's really important that your code can be ported because it just means you're not having to waste time having to rewrite or translate code for more devices. It's a really good idea that you use a language that's multi-platform. So something, for example, like Java, that can be used on lots of different devices, different operating systems, and so on, is a good one, and that's one of the advantages. It's really important that, as you've looked at in previous assignments, this is a factor for when you're choosing which language you're going to use, to make sure that it's quality in terms of its portability. It's really important that actually when you're writing the code that you factor in that it might be used on multiple devices. So are you going to write different versions of your program or your application to work with a PC, or different versions that will work on a mobile device such as a tablet or a phone? And you can even write within the same program kind of different versions or different features that will work depending on what browser you're using or what device you're using. So portability is really important, so that your software and your code can be used on lots of different platforms, can be used globally, and again, that it just saves a lot of time because you don't have to rewrite or make lots of different versions of it in the future. Maintainability. This means the ability to add new features, adapt the current features, change the program, or particularly fix any errors that you found. Why is it important? Well, obviously that the code will need to perhaps change over time. It might be that there are certain bugs or errors that weren't found when you tested it to start with. These need to be fixed. It might be that you've got to make updates. Perhaps there's security updates that you need to put onto it. Perhaps again changing with updated hardware or different devices. There might be new features that you want to put into it. There might be improvements to make it more efficient, make it faster as the coding libraries have developed over time. It might be that the actual software, the users have more requirements, things that they didn't need to start with. You've got to keep up perhaps with the competitors. So there's lots of reasons why you might want to update and make improvements over the lifetime of a piece of software. And again, its quality in terms of its maintainability is really important for these things. Just to say as well that good quality code will be easier to fix and update. So it will be easier to maintain and to add to, make improvements and so on. There are lots of ways that you can actually improve the maintainability factor of a piece of code. It's readability, so the way it's laid out, the way you've used comments, the way that you've structured your code. That's really important. So the structure, using modular code, laying it all out clearly, separating different functions and procedures from each other. The use of comments throughout your code, again to help future developers to edit and understand exactly how the program works. Makes it much quicker for them rather than having to really read it in detail. They can just understand it and know how to fix it. And also good technical documentation alongside your code to explain why it was written in that way, exactly how it works, what inputs it has, what outputs it has, how the processes work, and so on. All of these things will help the maintainability, which obviously is really important for the lifetime of the program and the code. So, just to recap, you've now covered all of these 6 points: efficiency, reliability, robustness, usability, portability, and maintainability. You just want to finish off your report with a little summary which talks about how all these factors mean that code is good quality, and this is important because, and you might want to mention a couple of things that you said at the start, such as, from the user's point of view, they want the code to run well. From the developer's point of view, they want the code to be able to be easy to understand so that they can maintain it, fix it, and so on. And this is all really important because software development is a very competitive world. It means that your software will stand the test of time, and it will be good quality code, good quality software that will stand up against its competitors, meaning that your company doesn't lose out money having to keep fixing things and losing customers. So just summarise up the report at the end.